questions from last time. So last time we assigned worksheet 1 from chapter 4. So let's take a look there and see if we have any questions from worksheet 1 in chapter 4. Miriam. Number 1. Sure. Let me do that. We're going to need a unit circle to reference. Let me grab one of those. All right. So the first thing that we want to do is we're going to look at the interval that we're solving over and figure out where on the unit circle I should be looking. So if I go to my unit circle, pi is right here. So if I go from pi, and because they're positive, we're going counterclockwise. Stop talking, please. To here, which is negative 2 pi, right? So we're covering quadrants 3 and 4. And it's tangent. So I remember on the unit circle, tangent is y over x. So if I multiply both sides by x, I need a place where y equals negative x. So what that means is that the x and y coordinate on the unit circle should be the same number, but opposite signs. So I'm going to go and look at quadrant 3 and 4 for places where the x and y are the same number, but opposite signs, one positive, one negative. So if I go look at quadrant 3, I see this place where they're the same number, but they're the same sign, so that's not what I want. If I look in quadrant 4, same number, opposite signs. So my answer I want is 7 pi over 4. And the last thing I need to do is just check to make sure that lies in between 1 pi and 2 pi. 7 over 4 is 1.75. So 1.75 is certainly between 1 pi and 2 pi. So I know that this answer is correct. Does that feel okay?
So you're just looking for something with over that question, you're looking for something with the same numbers but different signs?
Yes. Yeah, so if I get a tan problem, those are the hardest ones usually to decipher what it is you're looking for. But this is a situation where just like the x and y are the same, except for, one needs to be positive, one needs to be negative.
Oh, okay. Could you do like number 3, like sine? So like that's tangent.
Sure. So again, we'll go back to the unit circle and figure out where we're looking. So I'm going to erase all my marks. So that was pi over 2, which is here. And since we're doing a positive angle, we're rotating counterclockwise. So then 3 pi over 2 is here. So we're looking at quadrants 2 and 3. Now sine is y on the unit circle. So I'm just going to go and look in quadrants 2 and 3 for the place where the y coordinate is negative 1/2. So up in quadrant 2, all the y's are positive, so I don't need to look there. In quadrant 3, the only place where y is 1/2 is right there at 7 pi over 6. So 7 over 6 is 7 1/6. That's certainly between 1 and 1.5. So I'm good. Does that feel all right?
Yeah, and then like what if it wasn't between those two numbers?
Then you'd probably have to either add or subtract 2 pi to find an angle that's coterminal to the angle that you want that is inside the interval you're looking for. So if it was too big, we should subtract. If it was too small, we should add.
And that seems to like fourth quadrant.
Fourth quadrant?
I don't know. You said something where you always like add 2 pi.
Different kind of problem. Yep. That's if there's no interval provided. But on these problems here, you're just looking and checking. Yep. Does that feel okay? So again, should be relatively no work to show, right? Like I wrote down some stuff so you could hear what I was saying. But like realistically, all you're doing is looking at a unit circle and pulling the value, right? You just have to know where to look. And that's what I'm writing down, is talking about like how I know where to look. But realistically, when I do this, I write nothing down other than my answer, right? Because there's really no work I need to show. Especially for a sine and cosine problem. Maybe a tangent I can understand wanting to write something down to make sure you have your x and y sorted out. Lexi.
Can you go over?
Yeah, we did one. Just like, that was the first one we did.
Oh, okay.
I'm happy to do another, but we did just do one.
Yeah, I didn't notice that.
That's okay. Do you want to do another one?
Yeah.
Okay. Do you have a preference?
Number 4.
Sure. So remember, let's do the interval first, right? 0 to pi, what quadrants is that going to cover? 1 and 2. Good job. Right? So tangent, remember, is y over x. So if I think about the negative square root of 3 as like negative square root of 3 over 1, that would kind of imply to me that the y should be square root of 3 and the x should be 1. But I don't see any place on my unit circle where the x coordinate is a 1 and then the y coordinate's a square root of 3. But I do see a place on my unit circle where the numerator in the x coordinate's a 1 and the numerator in the y coordinate's a square root of 3. So that I can handle, because if I just multiply like the top and bottom by a 1/2, I get what I'm looking for. I want a place where x is 1/2 and then y is the square root of 3 over 2. And we don't know yet which one, but only one of them can be negative, right? I don't care which one, right? Because a fraction can be negative if the numerator's negative or the denominator's negative. So now I'm going to go to my unit circle, looking in quadrant 1. Well, if I look in quadrant 1, all of the coordinates are both positive, right? So that's not what I want. In quadrant 2, I see a place where x is negative 1/2 and y is positive square root of 3 over 2. That's what I want. So 2 pi over 3 is my answer. And 2/3 is definitely between 0 and 1. So I'm on the interval I need, so I'm done. Does that feel okay, Lexi? So again, the trick is, like having to start here and you'll figure out both your x and your y. And again, with tangent, it's always like if the thing is negative, it means either x or y could be negative, but not both. You can't tell from just, tangent being negative whether x should be negative or y should be negative. But you should never be in a situation where both could happen, right? You shouldn't have an answer that could be in quadrant 4 and quadrant 2 at the same time, because those are the places where one of the two is negative, right? Your interval won't cover 3 quadrants. So that just won't happen. You know what I'm saying? I feel okay? Not so bad, right? I mean, it's like a little bad, but it's like I've done way worse in this class, so like that's not so bad, relatively speaking, right? We're all a bunch of Albert Einsteins here today, and everything's going to be relative. That's a physics joke. All right. Should we move on? Yeah, we're ready to start. Let's do it, right? All right. So we're going to continue in section 4.1 today. And that's what I'm looking for. And we're going to do no new content. We're just going to look at another type of problem. Very similar to what we just did. We're just going to walk through some examples. Now, notice that this problem, the directions, almost identical to the previous ones, right? The setup, almost identical to the previous problems. The one difference is what sine or cosine or tangent or whatever is going to be equal to is not a unit circle value, right? That's a kooky decimal. That's not a unit circle value. What this tells me is I'm going to have to use my calculator to solve this problem at some point, right? I'm going to need a calculator along the way to do an inverse. Everybody's cool with that plan? All right. So the way that we're going to do this is we're going to draw a picture to help us figure out what equation I need to type into my calculator. So I'm going to start the same way. I'm going to take a look at my interval, and I'm going to try to figure out what quadrants my answer can be in. So 0, pi over 2, that's the start, pi to 3 pi over 2, and we've covered quadrants 2 and 3. Everybody happy with what I did there? Now I want to narrow this down a little bit further. I know that sine theta here is negative because, well, sine theta is negative 0.58, right? Now, on the xy axis, the y value, which is what sine is negative in quadrants 3 and 4, right? So that tells me that, okay, based on that, my answer could be in one of those two places. What is the overlap between those? Quadrant 3, right? Oops. Now, this reasoning that we did right here, I have an abbreviation for how we can tell what quadrant these trig functions are positive or negative in. So this is the way that I learned when I was a little whippersnapper. So I learned all silly turtles crawl. What those A, S, T, and C stand for is the trig function or functions that are positive in each of those quadrants. So in quadrant 1, the A stands for all sine, cosine, and tangent are positive in the first quadrant. In quadrant 2, the S stands for sine is positive in quadrant 2. If sine is positive in quadrant 2, cosine and tangent must then be negative if they're not positive, right? In quadrant 3, we have a T that stands for tangent is positive in quadrant 3. And so sine and cosine are negative in quadrant 3, right? If they're not the positive thing, they're the negatives. And then in quadrant 4, the C stands for cosine is positive in quadrant 4. So sine and tangent are negative in that quadrant. So I use that all silly turtles crawl acronym, or you can just think about like, what are the X and Y coordinates doing in each of those quadrants? You're doing the kind of the same thing. Everybody's okay with that? Okay. So what I'm going to do now is I'm going to draw a picture of my angle theta. So the initial side goes on the x-axis, the positive x-axis, and the terminal side is going to go somewhere in quadrant 3. Does it matter where in quadrant 3 I put that terminal side? Not really. It's fine. Wherever you want to stick it, just stick it in there somewhere. So this would be my angle theta. Everybody's so far so good? I'm now going to introduce another angle that we're going to refer to as alpha, which is going to go right there. Alpha is the angle made by the terminal side of theta and the part of the x-axis closest to the terminal side. The most common mistake students make in assigning their alpha is they put it between the terminal side and the y-axis. Always, always between the terminal side and the x. Everybody's good with that? It'll always be an acute angle, and it'll always be between the terminal side and the x-axis. You know, let's underline x-axis a couple more times to make sure we remember. So the way that we're going to calculate alpha is going to equal, in this case, sine inverse, because the problem is a sine theta equals problem, of the absolute value of 0.58, or negative 0.58. Why negative 0.58? Where's that coming from? It's in the question, right? Why sine inverse? Because it was a sine problem. Nothing magic going on here, right? Super obvious what alpha should be. Here's the catch. Most common mistake students make is not doing the absolute value. Got to remember to take the absolute value.
Wait, is that not? That's not.
Those are the absolute value bars here.
Oh, I thought it was a 1.
There. Put that in so everybody remembers now. Sure thing. All right. So now, here's what the picture is going to tell us. The picture is going to give us an equation that relates theta, the part of the x-axis closest to the terminal side, in our case that's pi, and alpha together. So let's look at the picture. What is the relationship between those? Well, if I start off doing theta, and I get to here, how far have I gone? So I started off at the beginning for theta, and I went all the way to here. We've gone, or pi, right? And then if we keep going to get to the end of theta, how far was that extra piece? Alpha. So theta must equal pi plus alpha. Because that's how we got to theta, right? We went pi and then alpha more. So now it's calculator time. That's all I needed the picture for, was to get that equation. But it's really important. That equation is going to be different depending on where on the x-axis, or on the, what quadrant, I should say, what quadrant your answer's in. So I'll do pi plus sine inverse, and then to get the absolute value, I'm going to press math, and then go to the number option, and then ABS stands for absolute value. Oops, a little bit of dyslexia there or something. So my answer should be 3.76 radians. I guess let's not box it yet. Is everybody okay with what we did to get that? Guess what? We can check this answer. You want to see how to do that? It's a two-part check. We have to check two things. First thing I'm going to check is that sine of 3.76, yada, 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 is negative 0.58. So sine of my answer, yes, that's step one of my check. Step two is that 3.76 needs to be between pi over 2 and 3 pi over 2. Well, let's see. Well, that's definitely bigger than pi over 2. And definitely smaller than 3 pi over 2. So I am convinced 100% that I have the correct answer, right? Because the theta satisfies my equation, and that value of theta is in between the interval required. Kate, of course. Let's do another example. Yes, sir. You are in degree mode. Radian. All right. Let's do another. So here we're going to do cosine theta equals negative 0.82, where theta is between 2 pi and 3 pi. Everybody cool with the plan? Okay. What do we start by doing? We want to draw our picture. And we'll start by figuring out what quadrant our answer has to lie in. Okay, so we start counting. So 0, pi over 2, pi, 3 pi over 2. Now we're up to 2 pi, and then 5 pi over 2, and then to 3 pi. Notice as I'm going along, I'm crossing out the value along the way, right? It's important that you're doing that. So I'm just updating the labels on my x-axis because I need those labels on my x-axis when I'm getting ready to draw my picture. So from 2 pi to 3 pi are going to be quadrants 1 and 2. Now I observe the problem is negative, so I'm interested in where cosine is negative. I see that cosine is positive in quadrants 1, all, and quadrant 4, cosine. So it must be negative then in quadrants 2 and 3, right? If it's positive in 1 and 4, it must be negative everywhere else. So where is my answer got to be? The overlap of the 2 in quadrant 2. Oops. So there's my angle theta. Notice that I went around more than once, right? Because my answer is between 2 pi and 3 pi. So I had to go around one full time to 2 pi and then to my answer, right? Okay. Now I'm going to draw in my alpha. The alpha is always between the terminal side and the x part of the x-axis closest to the terminal side. So there's my alpha. Everybody feel okay there? Okay. So now I'm ready to write my equation. So let's look. If I go to theta, I get to here. If I go alpha more, I get to there. And that's 3 pi, right? So I'll write theta plus alpha equals 3 pi. To get the theta by itself, I will subtract alpha from both sides. So theta should be 3 pi minus alpha. And now it's calculator time. So remember, the alpha is going to be cosine inverse of the absolute value of 0.82. Now, I'm not a crazy person, and I'm not going to type in the absolute value into my calculator every single time, because, Lord help me, I can do the absolute value of this in my head and save myself a lot of button pushing. What is the absolute value of negative 0.82? 0.82. Okay, so I'm going to stop writing down and typing in absolute values when I do this. I'm just going to make the number positive myself and save myself the hassle. You guys, I would encourage, continue doing the absolute value for a while until you've got it like drilled into your head, because it's real easy to forget. So especially when you're showing your work here early on, keep writing your absolute values in, because it is the number one thing I see students mistake students make is they stop doing the absolute value, because just like Mr. Kulik's done, he stops writing the absolute value and just doing them in his head. But when you go back and you look at your work, you don't see the absolute value in there, so you're just like, oh, just whatever the number is, that's what I do the inverse of. And no! Have to do the absolute value first. So here's my answer, about 8.82. So let's check that. So if I do cosine of that number, I get negative 0.82. Yes. And then I check. Let's see, is that bigger than 2 pi? Absolutely. Is it smaller than 3 pi? Yes, sirree. What does that tell me then? I got the right answer. Feeling good? Okay. All right, let's do one more. Now, what we're doing here is the hardest situation. How is this differing than the previous ones? It has nothing to do with the tangent. That's not our problem. It's that our answer can be or is negative, right? Our theta is between negative 3 pi and negative 2 pi. That's going to make this a little bit more challenging. I'll explain to you why in a moment, but nothing's going to change here initially. We're going to start the exact same way. So we'll start by drawing our picture. We'll try to figure out what quadrants our answer lies in. So this time it's a negative angle, so which way am I going? Clockwise, right? So 0, and then negative pi over 2. Negative pi, negative 3 pi over 2, negative 2 pi, that's my start, negative 5 pi over 2, and then negative 3 pi. So we're looking for our answer down here in quadrants 3 and 4. Oh, thank you. Here we notice tan theta is positive. Where can tangent be positive at? We're using all silly turtles crawl. Who can tell me? 3 and? Not 4. 1, because what does the A stand for? All of them are positive there. So obviously, where's our answer got to be at? Quadrant 3. Oops, forgot to write. Okay, so let's draw our angle. So again, we're going backwards. So we're going clockwise. So there's negative 2 pi. Keep going. So there's my angle theta. Everybody's okay there? Let's draw our alpha now. Again, always between the terminal side and the part of the x-axis closest to the terminal side, always x-axis. And now we have to find an equation that relates theta, alpha, and negative 3 pi together. Right? Between theta, alpha, and that piece of the x-axis that's closest to the terminal side. So what can we say? What equation could I write there? Is theta happening before negative 3 pi or after? Does theta stop before I get to negative 3 pi or after I've passed negative 3 pi? Before, right? So what would I have to add to theta to get to 3 pi? How far away from 3 pi is theta? Alpha, right? So we probably think this, correct? That's what our intuition would say, right? This is wrong. Let me explain to you why it's wrong. It's wrong because theta is a negative number. Negative 3 pi is more negative than theta, correct? To make theta get to negative 3 pi, we don't want to be adding alpha, which is always a positive number. We need to be subtracting because we need to be making theta more negative. So the idea here is if theta is a negative number, instead of like every time I think I'm supposed to be adding theta, or I'm sorry, adding alpha, I should really be subtracting alpha. Or if I thought I should be subtracting alpha, I should be adding. It's just going to be the opposite operation if my theta, if my angle that I'm searching for is a negative. But that's it. So to get theta by itself, I'm going to add alpha to both sides. And then it's calculator time. And again, I'm skipping writing the absolute values because I'm just doing them in my head. I'm going to say this every time I talk about how I'm doing one of these problems so that I continue to say the word absolute value over and over and over again so you guys are thinking about it, even if I'm not writing it down. So I have negative 0.829. Oops. And let's check that now. So if I do tangent of that angle, what should I be getting? Positive 2.17. And then that negative 8.28, negative 3 pi should be smaller, which it is because it's more negative, right? And then negative 2 pi should be bigger, which it is because it's less negative. So I'm convinced this answer is correct. Now, can I point out for a second what would have happened if we had boogered this and say we had left that as theta plus alpha? You guys good with that plan? Just to show you what would have happened. So we would have done this then in our calculator, and we've gotten that answer. If I did tan of that answer, look what happened. Did that check out? No, it's the wrong sign, right? That's your cue that you probably added where you should have been subtracting. Or if you dropped your absolute value, that also could be the culprit if you get something like that where it's just like, nope, not the right spot. I would also point out to you that this is also too small, right? That's also smaller than negative 3 pi. So it's outside of the interval also. So it's doubly wrong. This is where I want to stop today. I think this skill on its own is enough to work on as a standalone, and it's an important skill. Okay, we build on this skill in future chapters. This is an important skill to have. The key, again, to be able to do this is being able to draw the picture, right? What do we need the picture for? We need it to get that equation. How do we find theta? The picture tells us how to write that equation, right? That's the key. So, for you guys, what I'd like you to work on today is this worksheet 2 from chapter 4. You'll see it's like the exact same format as the examples we've just been doing. Everybody's okay? This will be due on Sunday along with worksheet 1. That'll be the problem set for Sunday. Anything we do on Wednesday or on the asynchronous day would be due the following Sunday, right? Not this Sunday, but a week from Sunday. Everybody's cool? Okay. Yes, sir.
Do you have any problems?
Not yet. That's my plan for the asynchronous day, is to assign some book problems.
Would those be due this coming Sunday?
A week from Sunday. Anything from Wednesday and the asynchronous day is a week from Sunday. Okay? At this point, I am going to stop talking, and I'm going to get out of your way and let you practice. Okay, if you haven't finished worksheet 1, do that. Or you could start right in on worksheet 2. You don't need to have done worksheet 1 first to be able to do worksheet 2. If you're like, yo, this is fresh in my head, let me practice this that I remember, and then I'll worry about worksheet 1 later. Cool, that's fine. Okay, but do some math right now. Okay, what do we got, like 30 plus minutes? I think there's 12 problems. If you can do 3 or 1 problem every 3 minutes, you could be finished. That's realistic. Maybe the first problem takes longer than 3 minutes, but I bet by the last problems they're faster than 3 minutes, right? So I think you could probably make up the difference.